Hello, I'm sorry for the delays. Yes, as David mentioned, yes, we work with emotions, and I can see a lot of frustration in the audience. Unfortunately, we haven't trained for that. So, yeah, my name is Javier Orozco, a data scientist from Realeyes, the company behind emotional intelligence. So the agenda for this presentation, pipeline, because they told me I should speak about Spark. So it's basically I will give you a brief introduction of who we are and how we measure the feelings of the audience via webcam. I will also give you a little bit detail of how we do it and how is the business actually measuring the feelings of the audience while they are watching online video content. I will also give you some details of how we perform this online, how we collect our data. I will present you with some use cases regarding the data collection, data analytics, and as well how we train predictive models for business KPIs. So, who we are? So we are the company that was born at Oxford University, but we have been incubated at the Central London. We are the leading company behind emotion intelligence. We work with consumer panels from all over the world in order to measure how the audience is feeling while they are watching video content over the internet. So what we use for that, we use just simply the webcam or any camera in their mobile devices or computers in order to measure these emotional reactions. So we are working at the moment with the largest data set of emotional reactions linked to social media performance. So just to give you an idea of what type of data or the extent of these data sets, we are at the moment at the records of more than 3 million viewers recorded for facial analysis, which basically translates into more than 80 billion data points that we are trying to leverage every day in order to build predictive models that allow us to build the ability to predict the earned media impact of the videos. So who are we working with? So we are working with the most exciting and important customers in the industry. We partner with brands, agencies, and media, customers that are really interested in understanding how the audience feeling against the content, against the product. So customers come to us with different intentions. For example, they come to us because they want to understand how the audience is feeling while they are watching the video content. They also want to understand what is the best way to advertise their video content, how is the reaction to the product, or basically they also want to understand how they can improve the performance of their KPIs. For example, sales, social media, any of these kind of metrics. Given the success that they have using our technology, this allows us to grow very rapidly and become the leading company in emotional intelligence. So now I'm going to give you a short video of how we perform emotion intelligence over the web.
Realeyes is the world's leading platform for measuring how people feel as they view video content. When people watch video at home or on the move, we collect their subconscious emotional responses by simply sharing their webcam. Test any demographic, anywhere in the world, and get insights from all of those responses in one simple dashboard. You can see, second by second, exactly how your audience feels about your video content. Whether it's a single video or entire campaign, you can view the highs and lows of your content's performance and compare this performance against your competitors, enabling you to make decisions that will drive results anywhere within the video's life cycle. It's what we call emotional intelligence.
Okay, so let's go into a little bit more details in how we do it. So let's start from the high level of the production chain, the process of building predictive models for business KPIs. So in this context, what we are looking after is basically how we can model or link the emotional and behavioral responses of the audience towards the business KPIs. So we look at all these emotional responses, which are converted or translates into time series analysis of every individual while they are watching the video content. We are looking in this time series for spatial and temporal cues that allow us to optimize the correlation of all this cognitive behavior towards the content that they just have been exposed to. So when we talk about business KPIs, we basically start from the hypothesis that human emotions drive the performance of the creative, of the video content. Yes, basically, we start from the premise that as humans, our emotions drive our behaviors. This is the reason why we believe that human emotions actually can be directly linked to the creative performance. So when we talk about different targets, we can talk about social media virality, for example, or sales lift, sales performance. So this is the main goal and main challenge that we have in predictive modeling. So in particular, I'm going to touch the point of predicting movie virality using YouTube statistics. So in this context, what we see, for example, is emotional and behavioral cues of this time series. In this particular case, we are looking at the engagement emotion. So what we can see here is that at any given particular point, the panel, the viewers, are telling us that they show higher engagement towards scenes that they are related to action. But this is a very localized cue. We also look at global cues where, for example, we can see that there is a global trend to increase the level of engagement by the end of the movie trailer. So another example is about negative emotions. So we can also notice that despite the content being designed to elicit positive reactions, this is the expectation from the producer, we can also see that the panel shows us some negative reactions. So we can see, for example, here that in some particular cases, the audience, the viewers, are showing a negative emotion. They can also show disgust or this type of emotions. But on the other hand, we also understand that the emotions are not only the very good predictors for a given target variable. There are also behavioral cues, the ones that they are not actually cognitive, the ones that the user does not control with their feelings. And these are about attention levels, the head movements, the way they approach the camera. All this level of interaction with the video can be captured via facial coding as well. So we also combine these behavioral cues because they cover a very wide spectrum of the video content, especially the ones that they are more factual. So the ones that actually are not always related to emotions or emotional expectation. So in order to develop a predictive model for social media, we need to establish a social media metric. So here what we do is that we combine statistics from the YouTube, such as number of views, likes, dislikes, and we optimize the correlation of these statistics with our behavioral, emotional and behavioral cues. So in this particular case, we combine these statistics, number of likes, dislikes, the number of views, the days that they have been released in the YouTube channels, in order to build the social media metric. So this is an example of how is the virality metric designed. So, as I said before, we do a combination of these three statistics, the number of likes, the dislikes, and the number of views, in such a way that actually we normalize these three statistics with the days that they have been released in the YouTube, in the way that a video has been highly scored if they have a very high number of likes and they have very high number of views, but at the same time they are penalized if they increase the number of dislikes. So, and to translate this into a target variable, we define a binarization process where we define that a video has a high virality if they have a high score within a subset of videos that actually have the same duration, the same time of being published in the YouTube, for example, 2 weeks. So how we proceed to collect the data? We saw a very brief description of the process of data collection. So the main idea is that first, customers come to us with single videos or entire campaign, and they define what is the demographic that they want to sample. So this is one of the main requirements that we need to match. After that, we prompt the viewers with an authorization to be recorded and allow us to record the video for face analysis and emotion reading. Then once the playback of the video content is finished, all these video recordings go over the cloud and we analyze them for facial expressions. Once we analyze the entire video recording for facial expressions, everything goes back to our dashboard. When the dashboard is updated, the customer can see everything. They see all the emotional readings, second by second or frame by frame. They can also see the social media predictions or any other predictive model that they have been signed up for. So in the particular case of the virality model, we have analyzed more than 10 emotional and behavioral cues, but we have seen that these are the main cues that actually maximally correlate with the virality predictive model. So how we do the modeling? So in this case, what we adopted was an ensemble of linear regressions, or as we also can call a mixture of experts. Why do we do that? Because first of all, we combine spatial and dynamic behavioral and emotional cues from different nature. So it's not the same to consider emotional smiles that can happen in a very spontaneous manner compared to other events like a surprise or attention. They have a different dynamics. So a mixture of experts will allow us to customize the discovery of these particular events. And on the other hand, it's something that is nowadays a very common requirement from many customers, is that they don't want a model that is actually robust and accurate, but also a model that they can explain, a model that can help them to explain why they obtain certain predictions. So they don't want the black box. This is why we adopt as well a simplistic model. So what about the performance? So after establishing our hypothesis of emotions driving the performance of the video content, we managed to understand that from this collection of signals, these are the the most important ones, especially in the movie trailers prediction. We understand that after looking at a wide variety of genres like action, drama, science fiction, that these behavioral cues were more relevant than others that they were fully emotional. For example, you can see here that attention is the best predictor in this ensemble of experts. So the performance that we have managed to obtain is that this model has managed to predict with a 74% accuracy whether a video is going to be viral within a window of 2 weeks. We also report here that we have achieved a 77% of ROC AUC. So what are the alternatives to use this predictive model? Well, this predictive model can be used to guide future creative decisions, media planning, and general benchmarking at the scale. So, for example, customers want to have 2 or 3 different versions of the same, 2 or 3 different trailers of the same movie, and they want to understand which actually is the most successful, or when they actually outline side by side the movie trailers, and they see, okay, this particular emotion, which one is eliciting more attention or more engagement, and what particular scene is actually more engaging than others. So this is the type of benchmark that the customer can do with this type of predictive models. Okay, so now I'm going to go in a different way. I wanted to present this content, which is about the examples. So the first thing is to talk about the way we collect the data and actually how we use Spark and Databricks in our data collection. So the first thing is that in order to obtain such a performance, as I said in the previous slide, we need good data. We need a minimum sample size in order to provide a model with significance. That means that in our process, we have a bunch of people that come into our website, but until they end up with the video recording and with actual emotions, we still a lot of viewers on the way. So in order to optimize for the best way to use the consumer panel, we need to identify at which part of the production we have any problem, like browser, computer, location. So we need to identify exactly what is the problem in the pipeline. So we need to identify also the quality, and we also need to scale this process. Why do we need to scale this process? Because basically we run campaigns multiple times in the same location. So we want to, at any given point, we want to compare how is the process going with respect to previous campaigns of the same nature. So that means that to do such a benchmark, we need to lift a comparison with our historical data. And as we saw at the beginning, we have a lot of viewers, 3 million plus, or we have about 80 billion of data points. So in order to be able to scale this process, we need to use a Spark. And the final thing is about deployment. So this is diagnostics that runs in real time, which means that concurrently we have different campaigns and viewers landing into our website watching video content. So that means that we need to monitor in real time different campaigns and do all this benchmark across different segments. So the only way we can deploy all these analytics in real time in a very intuitive manner is using Databricks tools such as very interactive dashboards, the ability to integrate external libraries like D3GS or LY, so that internal and external customers can intuitively interact with the dashboards and actually help us with the investigation. So one further step in the monitoring and diagnosis of this data collection process is at the stage where actually the user has agreed to be recorded. And what happens after that, or what we wish to happen, is that we end up with a recording. So we really need to emphasize at which point of this process we really need to do further investigations. So we do, as I said before, we do very intuitive pipelines, such as internal customers, for example, operations teams, that can help us to identify what are the problems in a particular data collection. And finally, we go through some basic checks, where basically what we are trying to do in this final step of the diagnosis is that we want to identify more particular failures in the data collection process. For example, what happens when there is a new release in Flash or in Chrome, Firefox. So that means that we want to identify that these could be potential problems in our recording pipeline. Why do we want to do that? Because basically we want to optimize the use of viewers and as well to optimize for the cost of the data collection. So that means if we manage to identify these problems beforehand, we can actually reject the users that they potentially will become a failure in our data collection. And the final use case is how we take all this data and build a test to guarantee that we have a robust predictive model. What does it mean, a robust predictive model? Basically, that we are actually reporting an out-of-sample performance. So in order to do that, we use the Spark scikit-learn package by Databricks, which allows us to basically test the robustness doing grid search, nested cross-validation, model selection, and parameter optimization. So in order to do that, basically what we have done is that we forked the original package for our own purpose. We forked it because basically we wanted to improve the broadcast of the data and the models into the workers in such a way that we only broadcast only one copy of the data in the models in the entire work in the entire node, such that the individual CPUs access this data or the sliced data by value. This will allow us to optimize the resources within each of the instances, and we can use all the CPUs in the instance without any limitation of the memory. So how does this work? So initially we have all the motions, the raw emotions. We create a central copy within the instance, and all the workers or CPUs of a particular node will access all this data to apply any grid search for pre-processing or signal extraction, signal feature extraction, the spatial and dynamic features that we use for modeling. Once all these features or signals are extracted, they are put back into the stack or cache in the central location. The next step will be to do the modeling. So once again, the previous data generated, like the signal or features, are accessed by value again from multiple CPUs in order to proceed with a further grid search for other type of parameters. And finally, which is actually that allow us to even gain a higher optimization, is in the cross-validation process. So the idea is that when you have, for example, a 10-fold cross-validation, this transformer will create a clone of the data for each of the 10 folds. Basically, if you do that in in a normal node with only 4 or 8 CPUs, basically you will need a very large node so that you can have all the memory to allocate all this data. But since we have a very large data set, this is why we keep it in a centralized location, and all this data are taken by value. So once the cross-validation is finished, then all the performance metrics are reported back to the master, and then we obtain, the conventional statistics for a cross-validation. This also allows us to do a more ambitious test, which is basically to have a grid search nested outside with a cross-validation. Why do we want to do that? Because basically we want to guarantee that both processes, model selection and parameter optimization, have been using only a portion of data that are completely seen. And there is a portion that is held out and completely unseen for all these different processes of parameter optimization and model selection. So before to go this, I think I should show you some example of the dashboards. Over there.
What would you like to do?
The dashboards.
Yeah, so you just click that. Just single click. Let's try this. Let's see which one's this. Oops. That's it, right?
Yep. Okay. So here is an example of the dashboards. So
switch out of it.
Yep. No.
Move it. There we go.
Okay. So here is an example of the dashboards that we use for data collection diagnosis. So basically, they are very intuitive, and they analyze all the steps that a data collection goes through from the very beginning, where we get a bunch of potential viewers. They go throughout all the process of being prompt, agreeing to be recorded, watching all the playback, and as you can see, there is a lot of spillage throughout all the data collection. So these dashboards are continuously being updated using the features from Databricks that allow us to schedule this in a job and be recurrently collecting and doing all the data analysis. The other example is these intuitive dashboards that allow us to integrate external libraries like D3JS or Plot.ly. So basically here what we are doing is that we are analyzing a current collection and comparing it across other segments. In this particular case, comparing to previous collections in the same United States. So we want to see actually in terms of the different processes of a number of emotions, number of collected videos, how much they are different or similar with respect to the previous collection, so that we can identify basically if they are behaving within the normal expectations or not. So should we proceed? Should we go to further investigation and probably take an action on that? And the last case is the one that relates more to the parameter optimization. So basically, what we just have here is that because of this particular time series analysis of spatial and dynamic features in the time series, we do all this process using Python. So for us, the most transparent and easy way to scale out was to use the Spark scikit-learn package. So as you see here, we have managed to test different experts at this level, different combinations for the out of performance metrics. The other conclusion that we can obtain from this robust testing is that we can actually identify at which point we are reaching or potentially reaching the overfitting limits. For example, if we stack too many classifiers, and we can manage identify, for example, if we are doing just a parameter optimization, and we obtain a very high performance. But when we do the proper nested cross validation, and this is 5 or 10% completely different from the in-sample performance, that we can probably question if we are in the area of overfitting. Okay, so what is next in this process? So we would like to build the next generation of social media predictive models, ideally using more Spark API to improve the scalability. And with respect to data collection analytics and real-time dashboarding, we would like to include predictive models as well in order to allow us to identify what are the potential failures in our data collection process, that we can actually reject these viewers that are prone to failure in an early stage, and of course to optimize in a better way the cost and the use of the consumers panels. Thank you.